Welcome to Caserta's Data Intelligence Series. In this series, we talk about what it takes to go from a good data and analytics leader to a great one. We'll share with you the tools and methodologies you need to build better, faster, and more robust, as well as strategies and frameworks to generate more revenue and grow your business. Featuring some very special guests and experts to inspire you and give you advice and direction on your data journey. And now, introducing your host, Caserta Data and Analytics Evangelist and VP Marketing, Remy Rosenbaum.
Everyone, and welcome to today's episode in Caserta's Data Intelligence web series. And I'm your host, Remy Rosenbaum. And today we're going to talk about how to deliver real-time insights without moving data. And as we all know, business leaders are all hungrier than ever for insights that are timely, relevant, and actionable. But to satisfy this insatiable appetite for analytics, the architecture needs to be able to deliver with minimal latency while not affecting application performance or complex streaming pipelines. But doing so effectively is easier said than done, like most things. So to answer this question and shed some light on how to do this, I have brought together two exceptional presenters for today. First up, we have our very own Brent Walter. Brent is a sales engineer with Caserta and has worked with clients across a broad range of regulated industries, from financial services to healthcare and research. He has a particular interest in leveraging data and technology to address compliance and risk management challenges. And up next, we have Benjamin Wood. Benjamin has made a career out of helping customers solve their organization's challenges around development, security, and availability of mission-critical applications with database technologies. He is a 13-year veteran of the MySQL organization, now owned by Oracle, and he assists federal and commercial customers by providing guidance on utilizing the world's most popular open source database. And we're going to hear all about that in just a few minutes. So first, a little bit of housekeeping and we'll get started. For those of you who don't already know, Caserta is a leading data intelligence consulting and implementation firm. We provide roadmaps, validate assumptions, implement advanced architectures, all things data and analytics. To start, all you have to do is reach out to us. And of course, our initial conversations are always complimentary. And if we find a fit, we can continue the conversation. And if not, we will gladly point you in the right direction. If you have any questions, I encourage you to ask them in the questions panel on the right. And our excellent presenters will get to them in the live Q&A at the end of the session. We will follow up with a recording to the email address you provided after today's presentation. And if you have any further questions, please reach out to me at remy@caserta.com. All right, first up we have Brent, and the stage is all yours.
Thanks, Remy. And is everybody able to see my screen?
Looks good.
Great, excellent. All right. Well, hi everyone, and thanks very much for coming along to today's webinar. So today we're going to be talking about analytics accelerators. Just a quick rundown of how the conversation is going to go. I'm going to start by describing a fairly common business problem, and then I'm going to go through some approaches that we've seen in the field. Some of them complex, some of them have worked, some of them maybe not so much. Then I'm going to talk about where analytics accelerators fit into the overall architectural picture. I'm going to walk through some considerations if you do decide to investigate these technologies further. Then I'm going to give a bit of a summary before I hand it over to our friends at Oracle to give a rundown of the Heatwave product. So to start off with the problem, let's imagine for a moment that you're a business and you're on the verge of going from being successful to wildly successful, which is of course where we all want to be. Your customers are demanding, and if you don't meet their needs, they're going to go elsewhere. You've built your business around an application stack that's running on standard OLTP databases. So things like MySQL. You might be running home-built applications. You might be running something like an ERP system. But your department heads are telling you that in order to keep customers happy, they need access to data. More than just access to the data, though, they need access in real time. Because, for example, there might be inventory problems that need to be solved in real time in order to keep customers happy. So the question is, if you've got applications and you've got data sitting in those applications, how do you get that to the business users as quickly as possible and as simply as possible so that the users are able to answer their business questions? So let's look at a first attempt. We might get a simple BI tool and point it directly at the application databases. Sounds simple enough. But if you do that, all hell breaks loose pretty quickly. So business users are going to start reporting slow queries. IT support is going to report that the applications are going down, or the applications are becoming unavailable because there are analytics queries running. Analytics queries being a very, very different beast to the standard OLTP or transactional queries that run against these systems. And customers are going to start complaining about service delays and service outages. So let's take a look at a second attempt. In the second example, we might simply replicate our application databases, right? Sounds simple enough. We'll create separate copies of the data. We'll refresh that data either periodically throughout the day or even transaction by transaction. And then we'll give it to the business users and we'll say, have at it. Sounds simple enough. But your business users are going to be pretty unhappy. While your applications and your IT support are going to be largely unaffected by this kind of pattern, your business users are still going to be really unhappy. They're going to be unhappy because queries are going to be taking minutes or hours or even days. And maybe the data won't be replicating fast enough to answer the kinds of questions that the business have. And so the business won't be able to respond to customer demands. So let's go back to the drawing board. Until recently, probably the most popular approach to solving this particular problem would be to build out some dedicated data infrastructure. And to be really simple about it, it looks like this. You put in place an ETL ingestion layer and you've shipped the data out to a warehouse. Again, sounds simple enough. And this is absolutely the right approach if you need to combine data from a lot of sources in order to calculate your aggregates, right? So this is where you can't constrain the calculation of your aggregate just to a single application. You might need data from multiple applications to bring together. But what if you're in a situation where your aggregates or the aggregates that you're calculating really only need to come from one or another application or database? Well, you're going to incur a lot of overhead if you build out a more complete data architecture. And you may not need that level of complexity in order to solve your business challenges. The other question that this particular architecture or this particular view of the architecture poses is, what about your real-time use cases? Well, this is where things get a little bit tricky, because you need to consider your ingestion layer. And there, you look at something like Kafka and you look at how you'll integrate Kafka streams into your ETL integrations and serve those up through your data warehouse. Then you've got to think about event sourcing, right? So how do I get the individual events out of my applications I'm interested in? It might be at the commit of each transaction, for example. And how do I push that down into Kafka? And I might install something like Debezium in order to harvest those events from my application. But then we end up with a fairly complicated solution, right? It's going to take a fair amount of time to implement. It's going to take a fair amount of management effort to manage the solution day to day, and it's going to be pretty costly by comparison, because each of these parts really requires different compute units. So if only there was a magic solution, some way of simply connecting users to data in real time or near real time, without moving the data and without changing our architecture fundamentally. If only there was something that could provide us with fast queries that are going to delight our users and ultimately inform our decisions. Well, this is where the Analytics Accelerator comes in. So a new generation of cloud solutions are coming to market, and these provide fast in-memory replication of data into a dedicated analytics layer. They'll intercept the query as it's thrown at the database engine, and they'll sort out the queries that are maybe calculating aggregates or doing things that the Analytics Accelerator or the acceleration engine is really good at. And it'll push the query down to that layer. This all happens fairly transparently to the user. So in short, what this is doing is it's providing your old school OLTP database with the ability to serve compute and memory intensive analytics workloads without the complications of a full data platform, and in a way that doesn't materially change your architecture. Now, while that's great, there are some considerations that we need to be aware of when we're looking at these solutions. While they provide a lot of flexibility for point problems, they can't always solve for situations where data needs to be integrated across different systems. So what can we do to solve a situation like that? Well, virtualization is one of the tools that we might automatically run to. And it's a really attractive option for combining with these acceleration engines. The accelerators are designed to, they're a really attractive option, but there are some things that we need to be aware of. Specifically, accelerators are designed to calculate and serve aggregates, right? So that is, we send it a query, we tell it sum these values up or average these values or calculate a moving average and give that back to me. And they'll do that really quick. But they're not particularly great at the kinds of data integration queries that are occasionally needed in a virtualization environment. So that is where we query from one system and we've got to push down a bunch of keys to another system, for example, in order to set a where predicate or something like that. And so our integration queries need to be really carefully designed if we go down a virtualization path. We also need to think really carefully about our caching strategies to make sure that the data that we're caching in the virtualization layer is as up to date as the accelerator itself. And the solution overall is going to require fairly careful monitoring because there is still the chance that you might start affecting your applications as the accelerator chooses not to process the query, for example. And ultimately, what this is going to do is restrict users' freedom to query because we're going to be constraining their use cases down to the ones that we've carefully defined within the parameters of our virtualization solution. So if you do have a situation where you want to give your users the maximum ability to be able to query across a broad range of sources, either from different types of databases, from different third-party data sources, and to manage things like user-created data, then what we're really going to need to look for is a more or less complete data platform, which is like one that I showed on a slide earlier. And this is the solution that really provides the maximum flexibility from an analytics and data consumption perspective. So in summary, analytics accelerators are an exciting additional option to consider as part of our overall technology strategy. They open up doors for solving a lot of point use cases really quickly. They can simplify our architecture where our needs are really focused on generating aggregates from SQL systems, and they can satisfy needs for in-application analytics. But it remains important to consider your needs holistically. And the message that we'd like to leave with you here at Caserta is that accelerators are an and part of the equation. They're not an or in your overall architecture. And if you've got any questions about this, please feel free to reach out to myself directly or to Remy. And now to walk us through Oracle's newest offering around analytics acceleration, specifically for the MySQL platform, I'm going to hand over to Benjamin from Oracle's MySQL team to walk us through that solution.
All right, thank you, Brent. Give me a moment here and I will transition to the content on my side. Remy or Brent, can you just confirm that things are coming through okay?
Yep. Looking good, thank you.
All right, so what I'm going to do is just take one small quick step back, and we're going to be addressing the things that Brent talked about very much from a MySQL context. So MySQL has a well-deserved reputation as an absolute OLTP powerhouse. We're behind the only cryptocurrency backed by a US bank. We power the majority of the high-volume websites out there. And we're a go-to for a wide range of high-end, high-performant, mission-critical systems. Ultimately, these operational systems end up generating data, and there's often a lot of value to be found inside of that data. And ultimately, then we want to mine that data for information with much more complex queries, OLAP-style queries. And there, you really have two options in the MySQL world. The first is to live within the inherent limitations that MySQL has as a database to process OLAP requirements, kind of the first generation of what Brent talked about, where you just take a BI tool and you point it at your MySQL server. And you're going to spend a lot of time optimizing, you're going to spend a lot of time with performance tuning, and ultimately you're going to hit an eventual wall. So in the end, at some point, many customers end up kind of going down to the next phase of things, which is bolting on an external solution specifically for these OLAP requirements and doing an ETL job to move their data there. And this is a common architecture. This is one that we see customers deploying in AWS, where they have MySQL as their operational system, in this case RDS. In Amazon, kind of the go-to analytics solution is going to be Redshift. You set up an ETL process, and you have your OLAP applications pointed there. But ultimately, all of these things are kind of interchangeable. We could say RDS could also be running MySQL on-prem or in Google Cloud. Redshift could be replaced with Vertica or Google BigQuery. In the end, these are all pretty similar things. Is this workable? Absolutely. Does this have challenges? Well, absolutely. Number one is we're starting to get into kind of a complex solution, right? We've got not only our operational data store, we have data warehouses, we have ETL jobs that require care, feeding, the talent, and all the software to make it work. Costs quickly add up when we start going down this path, and by nature of ETL being a bulk operation, we're not able to query against our operational data inside of our analytics environment because we're not seeing real-time data there. So workable, yes. Does it have challenges? Absolutely. And that's what we're doing with regard to the solution we're going to specifically talking about today, something brand new and an absolute powerhouse for OLAP solutions with regard to MySQL. It's a technology we call Heatwave. So Heatwave, very simply, it's an Oracle Cloud Infrastructure extension to the MySQL Database Service that transparently accelerates MySQL queries by 500 times. And I think the best thing I can do is to kind of unpack this sentence. We'll break it into a few little chunks, and I'll give you a really good idea of what Heatwave is. So starting off, this is an Oracle Cloud Infrastructure component. So Oracle Cloud, Oracle's been doing cloud-based solutions for a long time, providing high-end SaaS ERP solutions to customers. Oracle entered the public or general purpose cloud space only in the last number of years. We took a look at what the other cloud players were doing, and they did a lot of things we think in a great way. They're elastic, they're easy to use. But here at Oracle, we've again spent a lot of time serving very high-end customers, not only through on-prem solutions, but also through these high-end ERP cloud solutions. And so we took some of the things we learned there and are implementing what we call a second-generation cloud. That Oracle Cloud, we're very proud that we offer a better performance story, superior economics, enterprise expertise, a security-first mindset, and an open ecosystem. So the next part of Heatwave is we call it an extension to the MySQL Database Service. So at the bottom left, I'm showing you the console that you get inside of Oracle Cloud Infrastructure. You'll see a variety of resources available to you, big products like Exadata. You continue scrolling, you'll find MySQL. You click on Database System, and in a handful of moments, you'll have a MySQL Database Service system configured inside of OCI. As you're doing your configuration, you've got a number of add-on options that you can add on to your MySQL database service. It can be a standalone instance. We can do a very advanced form of high availability with our group replication technology. And then you can also add on Heatwave. So ultimately, it is an extension to the MySQL database service. And Heatwave is comprised of a bank of high-speed specialty analytics servers. The way this works is transparent. So all of your data exists inside of regular MySQL, inside of InnoDB. And we're also keeping another copy of your data inside of these Heatwave servers, except now the data is stored in a columnar format, it's compressed, and it's in memory. So when you connect to the MySQL database service and you run a insert, update, delete, or maybe a simple select statement, that query is just going to be run natively by MySQL. Whatever change necessary will be propagated to Heatwave, and the results are returned to the end user, just business as usual. But if you send a more complex query to MySQL, our optimizer will determine if this is sufficiently complex that we should offload the query to this bank of specialty OLAP Heatwave servers. Heatwave will process that request and then send the end user back transparently the information that they're asking for. The only thing the end users notice is the fact that things are much faster than before. So One of the reasons that we offer higher performance is just by nature of how we store things in Heatwave. We talked about it. It's columnar, it's compressed, it's in memory. We also do a lot of magic in distributing the data that allows a vast level of parallelization. Essentially, every core inside of the Heatwave cluster can attack an individual query and offer massive parallelization, along with vector processing and a range of just amazing technologies that we use to make this work really fast. And when we say really fast, one of the benchmarks we did was using the TPC decision support benchmark, and we compared Heatwave against a regular standalone but big MySQL server that had 512 gigs. And when you take a look, these are the queries that we ran with TPC decision support, and the magic number is all the way across the bottom there. If you take a look at that first query, Heatwave enabled versus a standalone regular MySQL system, we accelerated the query by 537 times. The next query, 760 times. And if you average it out, that's where we come up with that number of 500. Obviously, every workload is going to be dependent on the queries and the data, but TPC decision support, 500x performance improvement. Really quite amazing. But what happens if we take a look at that earlier customer example where the customer was abandoning MySQL for OLAP purposes and using a product like Redshift? Well, we've done some early benchmarks to compare how Heatwave does versus Redshift. And ultimately, we are considerably faster. So in this case, we ran a 4 terabyte decision support TPC-H benchmark, and MySQL Heatwave is about 3 times faster than Redshift and about 3 times less expensive. And because this is transparent and it's real time, we're able to query against real time data, not having to wait for that ETL job. So what happens if you're a customer with a deployment like this? You're making use, again, of some sort of MySQL, you're making use of some sort of bolt-on analytics process. How is it that you can take advantage of Heatwave? So I've got 2 options for you. The first option is obviously you can take your entire application stack and move it up to Oracle Cloud. It's going to be a very simple deployment because ultimately now you only have one database. It's MySQL Database Service with that Heatwave component enabled. This is simple. We give you an improved total cost of ownership, and you're able to query against real-time analytics. But what if you're not ready to move everything to Oracle Cloud yet? Well, we've got a second option for you, which is really kind of keep everything where it is today, but spin up Heatwave. Native MySQL replication is very simple to configure. So whatever is going on inside of your operational transactional environment is automatically being streamed to Heatwave living in OCI. And then your OLAP applications, again, really living wherever you want, can simply connect to Heatwave. We still give you those same advantages. This is still a simpler solution. We're eliminating those complex ETL jobs. Heatwave, as we already saw, is less expensive than other specialty analytics solutions, and this is real time. So pretty much all the advantages that we mentioned earlier, just kind of doing one piece at a time. So again, Heatwave is an Oracle Cloud Infrastructure extension to the MySQL Database Service that transparently accelerates your queries by 500 times. And so we've talked about Heatwave as an alternative to specialty analytics engines. Heatwave is also a great general purpose MySQL query accelerator. We've got customers who are building out SaaS applications where they want to offer more complex visualized information as part of their SaaS application, but they're running into performance issues. Simply dropping in Heatwave is a great scaling and, again, general purpose performance tool that you can easily add on to an existing application. And when you kind of combine these things that Heatwave does, it's simple, it's less expensive, it's faster, it's real time, you end up with something that's more than the sum of its parts. If we had something that was just way faster than everybody else, well, that would be great. But not only faster, but you combine these other attributes, ultimately what it allows you to do is to do a better job in unlocking the value that's sitting inside of your data. We're getting rid of those barriers to entry to be able to dig down and take advantage of the information that your MySQL operational systems are developing. If this sounds exciting, we've got a number of options for you. So we've got a trial of Heatwave that you can do as part of a free Oracle Cloud trial that will give you $500 in credits. We can also help you with loading your data and executing your queries. We call it a Heatwave Performance health check, and certainly we're happy to help you with a range of questions. Ultimately, reaching out to Caserta is going to be your best next step, and ultimately they can involve folks from my team to be able to help you with the health check should you like to go down that path. So ultimately, appreciate your attention for the introduction to our Heatwave service, and I'm going to turn things over to Remy for the next step here.
Hey, thank you so much, Benjamin. And now we're going to go back to Q&A, or we're going to start Q&A. So if you haven't already asked a question in the questions panel on the right, please feel free to do so now. And I think we have time for just a few questions. So I'll start with the first one. I have data from many non-SQL sources. How would this work with Heatwave? Benjamin, that would be for you.
Okay. It's a great question. So ultimately, I would pause and kind of consider what Brent talked about earlier. If you're really looking for mass ingestion across a huge range of other products, kind of going down that data platform process would probably be the better solution. But say you've got 80% MySQL data, and then you've got some other data from SQL Server that you want to join in. Well, Oracle Cloud has got Golden Gate that also has Oracle Data Integrator. We've got native, very simple PaaS services that we can use to pull those kind of extraneous data sources into Heatwave and to be able to kind of query against that unified view. So again, consider what you're doing strategically first, and then we've got a number of tools that can really help you with that.
Okay, great. Brent, did you want to chime in on that from your experience?
Yeah, so I mean, to Ben's point, or to Benjamin's point, it can be a really complicated and challenging problem to blend data together from all sorts of disparate systems, and particularly when we've got to consider that it's not just our standard databases anymore, and this is where cloud can be really, really powerful. And all that we do all day at Caserta is design these kinds of solutions to achieve those kind of integrations. And as an Oracle partner, we're more than happy to help you out with your journey in that direction.
All right, thank you. Next question. Can you clarify what you meant by restricting user freedom to query? I think, Brent,
Sure.
that goes back to you.
Yep, sure. That'll be for me, and that was with respect to virtualization. So really, this is pretty basic. So if you want to give users, maximum ability to run really, really complicated queries, you need to give them the infrastructure that the kind of infrastructure that isn't going to fall over when you fire a really complicated multi-source type query at the database engine. Now, if you're putting a virtualization solution between you and one of these acceleration engines, a lot of the data integration work that needs to be done can't really be pushed down into the accelerator engines, or at least if you do, then you lose all of the value of having the accelerator engine in between. So in order to get around that, what we need to do is sort of think really carefully about the way that we define the views that are available to users through the virtualization solution, and make sure that they're optimized to take advantage of the accelerator engine. And the only way that we can do that is by understanding a lot more about what our users' individual use cases are, and then designing specific solutions for that. And that's what I mean by constraining the use cases.
All right, thank you, Brent. And that is all the time we have for today. So if we didn't get to your question, please feel free to send it to me, remy@caserta.com, and we will definitely get it answered by the presenters. Thank you, everyone, and I'll see you next time.
Thank you.